All right, I'm going to go over number 2 under Charles law as an example and go over the steps on how to solve these kind of problems. So it's pretty similar to what we had done on Monday. So third period, I know I saw you Tuesday, but first and second period, I didn't see you Tuesday. All right, so Monday you have this worksheet. If you need the worksheet, it is available to you on the side table where the hand sanitizer is. You can pick up one of the packets. All right, so we went over Boyle's law and how to solve V1P1 equals V2P2. We went over that on Monday. All right, if you have questions about that, you can see me on Thursday. So today I want to go over Charles' law, and what you see here, it's kind of similar, except here we're talking about the relationship between volume and temperature. So V1 and T2 are referring to volume and temperature. V1 is the first volume you will see. T2 is the second temperature you will see. V2 is the second volume you see. T1 is the first temperature. It's a little bit confusing because you don't have the ones on the same side and the twos on the same side. So watch out for that. Also, T, temperature, must be in kelvins. And kelvins are 273 plus degrees Celsius. So let's see how this works out. We're going to look at number 2. And I can't fit it all in here. Let me move this a little bit. Okay, that looks better. A little bit. So a weather balloon is filled to a volume of 150.0 liters. All right, so there we have a measurement, and this is going to be our first volume. Okay, so I'm going to list that over here. V1 equals 150.0 liters. All right, filled to a volume of 150.0 liters on a day when the temperature is 10.0 degrees Celsius. So here is our T1. I'll write that here. Right, T1 equals 10 degrees Celsius, or if we're going to put that in kelvins, Kelvin is 273 plus 10 equals 283 degrees Kelvin. Actually, it's not degrees. My mistake. It's just 283 Kelvin. Okay, so we got our temperature in kelvins and our volume in liters. What else do we have here? If no gases escaped, what would be the volume? Oh, so here they're going to ask for volume, but we don't know what it is. Okay, so our second volume is something that is unknown. That's what we're going to calculate. So what would be the volume of the weather balloon after it rises to an altitude where the temperature is -8 degrees Celsius? So that's our second temperature. T2 is -8.00 degrees Celsius. Or if we're going to put that into kelvins, again, it's 273 plus -8.00. This equals 265 kelvins. All right, so we have our V1, our T1. We don't know V2, we have our T2. And did we remember to convert everything to Kelvin before we calculated? Yes, we did. So we use the, what do you call it? You know what this is. My brain's not working. The equation here, V1 T2 equals V2 T1. So let's write that down over here. Here's all our information on this side. Our equation is V1 T2 that I get from up above at the top of the page equals V2 T1. And now we just plug in for the values that we have. So V1 is 150, so let's plug that in. T2 is here, so make sure you're using T2 and not T1. It is 265. and this equals V2, which is unknown, so we're going to leave that as V2, and times T1, which in Kelvin is 283. Now we just calculate. So calculating 150 times 265 equals 39,750 equals, we can't do anything here, we still have V2 and 283. In order to get rid of the 283 and get the V by itself, we divide both sides by 283. And this cancels that out. So now we have 39,750 divided by 283. And we have 140, whoops, let's write that correctly. 140, I'm gonna round that just to 140. And this is volume, so this is liters, is our V2. Okay, and does this make sense? So we had a starting volume of 150 at temperature 283, and we went down to 265. So we would assume the volume would go down, and yes, it did. All right, so that's my double check. That's question number 2 on the page with Charles' Law. Okay, so if you have questions about that, and this doesn't help so much, you still have something you need to ask me, let me know on Thursday. All right, I'm going to go to the next page, which is Gay-Lussac's law. And this is now pressure and temperature instead of volume and temperature. And it's P1 T2 equals P2 T1. And I have information here about standard temperature and pressure. Standard temperature can be either 0 degrees Celsius or 273 Kelvin. It's the same temperature, just expressed in different ways. Standard pressure, again, these are all the same pressure, but expressed with different units. Either 1 atmosphere, 101 kilopascals, or 760 millimeters of mercury. So all these are the same pressure, but measured in different units. Okay, and because I did number 1 and 2 with period 3 Tuesday, so I'm going to go down to number 3. Okay, so a gas occupies a volume of 50 milliliters. All right, so here we have a volume, and let's write that down. V1 is 50 milliliters, but I'm going to put this in liters. Okay, so putting this in liters, we would multiply this times 1,000 to put it into liters. No, divide. Divide by 1,000. I'm like, what is this going to be? I know I have to start with a 0. All right, 1, 2, 3. That gives me 0.05 liters. All right, we need to have our units in liters for this. And it gives us a temperature. So our T1 would be 27 degrees Celsius, or 273 plus 27, equals 300 Kelvin. And this gives pressure in millimeters of mercury. So this is our P1, 630 millimeters of mercury. And then the question is, at what temperature? All right, so we don't know. It's asking us something. That's our second temperature. Now that they want it in Celsius. Would the pressure be 760 millimeters of mercury? All right, so our P2 would be 760 millimeters of mercury if the volume remains constant. So it's telling us the volume is constant. Constant means same. So if the volume is constant, that means it never changes. So our V2 is still going to be 50 milliliters. Divided by 1,000 equals 0.050 liters, which I guess we don't even need this because volume is constant. Oh, did all that work for nothing. All right, so did I remember to convert temperature to Kelvin? Yes, I did. Our T2, what is it? We don't know. This is what we're solving for. Okay, so the reason I don't need the volumes is because it's constant. If something doesn't change, we can use an equation that doesn't have that in account. So we can go back up here, and this is part of the problem anyway. Our equation that we're working on this page is P1 T2 equals P2 T1. So I'm going to write that down here. All right, this is all our information. We're going to solve over here. P1 T2 equals P2 T1, and plug in and solve. Yeah, I'm making a video for tomorrow. Yeah. All right, so P1 is 630. Our T2, we don't know it. And then our P2 is 760. And our T1 is 300. So let's do the math. We're going to keep this the same because we can't multiply a number and a variable. We'll figure that out later. And then we're going to multiply 760 times 300, 22,000 or 228,000. Cool. Now we're going to divide both sides by 630 so we can cross cancel, and we get T2 is divided by 630. What? Why did it tell me like that? Let's start over. 228,000 divided by 630. Why is it giving me a fraction? All right, I gotta go get another calculator. Excuse me while I go fix this problem. Generally, I use my phone as a calculator, but I'm also using it as a device to make the video here, so that's not going to work. All right, but I'm back now, and let's take a look. 228,000 divided by 630. That looks better. 362 Kelvin. I'm just rounding up to the nearest whole number. And does this make sense? Let's take a look. We have our T1 is 300. Our pressure went up, so we figured our temperature should go up, and it does. So this works. I like it. Okay, so again, if you have questions about this and you're not sure even after this explanation, just make a note of it. Maybe write something on your paper right here, and you can ask me about this tomorrow. All right, I'm gonna go to all right, maybe I'll do 2 more. We'll see how we do here. Okay, so now we're looking at moles and volume law. Okay, so now we're going to be looking with moles and volume. So V1 is going to be your first volume. N2 is your second number of moles. V2 is your second volume. And then N1 is your first number of moles, right? Tells you N is moles. All right, so I'm going to do number 2 here. So if we have 7.50 moles, actually let's include our units in there too. That's going to be our N1 of nitrogen occupies 4.25 liters. That's our V1. How many moles of nitrogen? We don't know. That's our N, but we don't know what it is. That's N2. Would be present if the volume were 12.5 liters. All right, I hate it that the unit is over here and the number is over here. I would have changed that if I'd caught that. I'll just put L here, and this is going to be our V2. Okay, assuming pressure and temperature remain constant. All right, so let's write all that down. We have our N1 is, that's an ugly N. N1 is 7.50 moles. Our V1 is 4.25 liters. Our N2 is unknown. We're going to solve for that. And our V2 is 12.5 liters. So we're using the equation from the top here, this equation here. I'll write it down so we've got it all together. We have V1 N2 equals V2 N1. Plug in 4.25 for N1. N2, we don't know it, so we're just going to leave it as N2. V2 is 12.5 and N1 was 7.5. 7.50. So let's do the calculation. We have 4.25. Oh, we're not going to do that. Never mind. 12.5, right? 12.5 times 7.5. This equals 93.75, and over here we still have our 4.25 times N2. We can divide both sides by 4.25, so we can cross cancel, and N2 is 93.75 divided by 4.25. And this is 22.1 moles. Does this make sense? Let's take a look. So if we have, it's all nitrogen, our first volume going to the second volume is 3 times as much. All right, and we would expect this to, in order to stay the same pressure and temperature, you'd have to have 3 times as many moles, which it pretty much is. That works. All right, again, if you have questions about this, you can let me know on Thursday. All right, last one. All right, last one. Whew. Okay, so this is the combined gas law. All right, so at this point, I will have done one problem on every page after I finish this one here. So the combined gas law is P1V1 times T2 equals P2V2 times T1, okay? Where you have pressure, volume, and temperature, okay? Or there's V1 P1 divided by N1 T1. Okay, this is the PV equals nRT equation. All right, let's go through problem number 1. If we have a 0.28 liter sample, it exerts a pressure. Actually, let's get all these written down. Otherwise, I'm gonna go crazy here. So 0.28 liters. Pressure is 0.8 atmospheres. That's our first pressure. And we have 26.0 degrees Celsius as our T1, 26 degrees Celsius, or if we're gonna calculate it, because it needs to be in Kelvin, right? Temperature must be in Kelvin. Remember to convert. So 273 plus 26 equals 299 Kelvin. Okay, at what temperature, okay, so we don't know this, that's unknown. Our T2 is unknown. Would it exert a pressure of 1.5 atm? So that's our second pressure, 1.5 atm, and a volume of 0.44 liters. Okay, So we converted to Kelvin, we're good. We can set this up. So we have the combined gas law, P1, V1, T2 equals P2, V2, T1. So this is all the same except now we have 3 variables. Pressure 1, 0.8. Volume 1, 0.28. T2, unknown, just write T2, equals pressure 2, 1.5, V2, 0.44, and then T1, 0.28. I did something wrong. No, 299. All right, let me double check. All right, so our P1, cool. Our V1, cool. T2, unknown. P2, 1.5, V2, 0.44, T1, 299. Okay, I got it. It's always good to double check yourself. Now we calculate. So if we calculate 0.8 times 0.28, that's 0.224 times T2. And we'll have to divide at some point, but let's multiply these guys first. So clear. Multiply 1.5 times 0.44. Oh, whoops. And then times 299. Okay. 197.34. And now we divide both sides by 0.224. 0.224. Cross cancel. T2 equals 197.34 divided by 0.224, 881. Let's round it to the nearest whole number. So rounding the 0.9 up to a 1, and this is in kelvins. And does this make sense? We had a low temperature 299, but we are like doubling the pressure. We're also increasing the volume. Seems like it would kind of even out, but looks like I did the math right. I did this one before, I got the same answer. So that's probably right. Looks right to me. All right, so that's how we do the ones with the combined gas law. P1, V1, T2 equals P2, V2, T1. Again, if you have questions about this, not sure what's happening, then just let me know Thursday. Okay? And there's that. I'll have this posted in Google Classroom so you can open this up and check this out at your leisure. All right, thank you.